So here we have our AI agent currently searching the internet to find out when did William Wallace die. It says August 23rd, 1305. I wonder if I paste that in online, what will it tell me? Was when William Wallace died. There you go. So in today's video, we're going to create this AI agent that can access the internet. It's going to be a low-code solution, so pretty much no code. There's going to be one little chunk, but don't worry, I'll share it with you. And we'll be putting it into our web scraper tool, which is this here. And again, don't worry, I'll be walking you through this whole thing. But the one thing I want to point out is that we're going to be using Crawl4AI, which is an open source LLM-friendly web crawler and scraper. What's a web crawler and scraper? Well, if you were to go on Google and search in this here, for example, all of this content that you can see, all this text and image content, you might want this information, and you would have a scraper scrape this information from the website so that you have it at hand. A web crawler is something which would move through and click on the links to then go to the next page. So a web crawler and a scraper can essentially go on the internet and get loads of information, which is cool. Now the reason we're using that is because the original method I had tried, which is just using a very simple GET request, doesn't work. And I'll tell you why. So first, a little bit of background. What is an HTTP request? You have right? And you're using a browser, say Chrome, right? And when you put in a URL, your browser then sends some HTTP GET request with that URL to a bunch of network stuff, but essentially to the server, i.e. the other computer which hosts this URL. So basically it says, get this website for me. And then that will send back their website, which will be like an HTML file and some JavaScript and stuff, right? And then your browser will render that HTML. So in theory here, if I could just get the LLM to just do this request, I could theoretically get this HTML back, and then I would have the web page. And now LLMs are trained in all of the data on the internet, so surely they know how to do this, and they know how to parse this, i.e. how to read it, right? So that was my original idea. And I did implement this, and I'll show you how, but it doesn't work. Or it kind of works, but there's a bunch of problems. And those problems are fixed by using Crawl4AI, as well as using RAG as essentially a vector database that we can use to minimize how much information we have to give the language model at any given time. So here we have my why you need a web scraper flow, which is an AI agent here. We've got a model, Grok model. Grok is a free API endpoint for large language models, so you don't have to pay, but it is limited, so there's only a certain number of tokens you can use, which we'll get to in a minute. We have a memory, so it can remember some of the messages you've said in this specific session. And then we have a couple of tools. On this tools, we've included Wikipedia, so it can search Wikipedia, which is pretty cool. And then we have this HTTP request workflow. Now, if we go and see this HTTP request workflow here, essentially we use the HTTP request tool, which if you recall from that, it's this is HTTP request, and it's just a GET request. So we have a tool that's built into n8n for this, and all you have to give the tool is a method, i.e. GET, and a URL, like Google, right? So very simple, it already exists. So we can pass this tool directly to the AI agent. And the thing that is amazing and blown my mind is the AI agents actually can go and use it. Like it just figures out itself to go use it. Like if we double click here, you can see, and don't worry about following along with this, we'll do an actual step-by-step creation of this here. So don't worry about the specifics, just try and get the gist of what's happening. HTTP request method, right? And then the URL, which we had just shown you here, right? This method and URL, we're letting those be defined automatically by the model. So we're not telling the model what it is, we just give it a name and we say, you decide what it should be. And then it figures it out, which is amazing. So this does work. It will go on the internet and find stuff, but then when it brings it back, it can either just run appearingly indefinitely, so forever, or it just dies out because it reaches a token limit. So that kind of hints at what are the problems with only using HTTP GET request, i.e., why are we using Crawl4AI in the first place? Well, the first problem, which we had just said, is tokens. So, what are tokens? Tokens are the units that you send to a large language model. Now, large language models obviously use text, i.e., strings. A string is just text in computer speak. And then a letter is called a char or a character in computer speak, right? And so this word tokens doesn't get passed in to the LLM as tokens. An LLM will decide how it should be tokenized, and it could be tok as one token, en is one, and then s is another, or it could be, to and then kens, whatever, right? Doesn't matter. But the point I'm trying to get at here is that one word could be more than one token. So what happens is a normal LLM would have like a 128,000 token limit, something like that, which sounds like a lot, but it could maybe be, say 70 or 80,000 words. Now that seems like loads. When would you ever send in more than like 70,000 words? Well, if we come back to this here, if we wanted the LLM to go to this Google page and get this information, for it to be able to read this information the way you and I are looking and interacting here, if we right click and we go to inspect, this will open up the developer tools section. And from here we have elements, and this elements is your HTML file. So this is what's coming back in your GET request here. So we have this HTML file here, and you can see if we just scroll down, there are loads of words, essentially, loads of what could be tokenized. And you can see that even just like these divs, for example, these don't really mean anything. They're just closing out these other ones. You can see each indentation is like a new layer, but they're still words which have to be tokenized. Additionally, if you see these three little dots, if you click on that, that's because there is more text. Look there, load, right? So suddenly, if you have all of this, let me see if I can copy the whole thing. Okay, Command A. No, I don't think so. If I do this, no, I don't know. Basically, what I'm going to get at is that this could be 70,000 words, especially if you're going to then have like 3 or 4 web pages. So the problem becomes, how do I use that, right? Well, the Crawl4AI is able to just get the information that you need. Ish. It removes loads of the fluff around this, right? Which is good because then suddenly it reduces the number of tokens, which is great. Now, the second way that we can reduce tokens is also the kind of second problem here, which is no memory, right? So if we just do a simple HTTP GET, we have to do it every time, and say part of the answer is on this web page, part of the answer is on another web page. Well, we would have to pass in both web pages, right? And if you checked it in a previous session, so like a different chat, and then in this chat we'll try to do it again, we'll have to go and find it again and try and scrape the page and blah, blah, blah. And suddenly you get a bazillion tokens and loads of processing power, and it's a nightmare. So the way to reduce the tokens again is to introduce a memory, specifically a vector database. So if we open up here, which is our web scraping subflow, so essentially this flow here, this web scraping flow, this is a tool that we pass in to the AI agent. And in here you can see that we have a Superbase vector store. Superbase is just a vector database provider. They're essentially a wrapper for Postgres, as far as I can tell. Postgres just being a popular SQL database provider. SQL being a popular language used to create tables. So really it's just a big glorified database table place, right? So that we store in there the web pages. Why? Well, as I was saying, the tokens here, if we were to pass in a web page, right? Say an entire web page, a gazillion lines. If you're to pass this in, this could be, whatever, 60,000 tokens. You want 2 web pages, 120,000 tokens. You want 3 web pages, 100, whatever, I lost track, 180,000 tokens. Too much, can't do it, boom, you're done, right? So what we could do instead is if we're able to put these in a vector database, we would be able to chunk these up break them into sections, right, and store each of these sections. Now, the beneficial part here is that then before we even consider passing it to the LLM, we can first do RAG, Retrieval Augmented Generation. So we can have a search, go and be like, right, what's the query? The query is, what colour is a Labrador? So we could then, instead of going and getting all of these Google pages, which are Labradors, Labrador colours, dog colours, whatever, right? Instead of all of that, we could just take one chunk which specifically talks about Labrador colours, and then another chunk here which talks about, if that's different depending on different Labradors or different dog breeds or whatever. I don't know anything about dogs. That was a bad query. But you get the point, is that it can then go and take these little chunks, which if we say this was, 60k, 60,000 tokens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, divide that by 10, 6,000 in each chunk here. And if we have 3 chunks, 6, 12, 18,000, which fits in here so much better. Now, additionally, memory, it brings in memory, because now if we kill that chat session and open up a new one, it can then come back and reference these essentially pages of the internet which you have stored in your vector database, which is cool. So the third problem is that we have the HTML, right, which is cool. If we go back here, we have the HTML, which is cool, but we don't have any dynamic content. So for example here, if you were to scrape this web page, you would get that, right? We would get people also ask, what does an HTTP GET request do? But we wouldn't have the information which comes when you click on the button, because it's hidden, it's dynamic. And so this dynamically injected code or content, we can get that if we use Crawl4AI. So it solves that dynamic content problem, and it allows us to actually get all of the information from the page. Now, number 4 is asynchronous/synchronous data processing. So synchronous data processing is like A to B to C, blah, 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 right? Asynchronous would just be the A, B, and C all get run at the same time, which means that if this was in steps, that they would all get done in step 1, whereas here it would take 3 steps to do it. So if we were to do this using our own HTTP GET, we would have to wrap this in some weird code to try and make it asynchronous, to try and make it run like this. Crawl4AI automatically does this, which is great. So, for example, what that means is if you give it a URL for an entire website, it can asynchronously get all of the pages of the site, as opposed to one, then one, then one, then one. So that's cool. Finally, the 5th one is that we have to advanced data extraction. So as I had shown you, that HTML is a nightmare to look at. To try and get the right click and inspect, to try and get the specific information we're after, it's just going to be an absolute nightmare to try and find anything here. And if you were to try and code this, the amount of like pattern matching regex you would have to do wouldn't even be funny. And you'd have to already pre-look at this and figure out what you want and stuff. A nightmare. So Crawl4AI does that for you. So why are we using it? It will reduce our tokens. Then we've included VectorDB, which will then bring memory and reduce tokens again. It then handles dynamic data, processes asynchronously, and it will handle complex data extraction. So now we know that why we're using Crawl4AI and not just something simple like this. Let's start building. So we're going to build this here. Quick reference is that here I'm using the OpenAI chat model because Grok, and I had a look online, if we open up Grok is a free API provider for LLM inference. Essentially, when you want to talk to an LLM and you want to programmatically do it using an API key, you can get it on Grok for free. The problem is, most of the free models on Grok are Llama based, and Llama doesn't like to work with JSON objects. It doesn't see it as a string. Essentially, what that means, if you don't know, is that you have, say, like a JSON object, which would be some curly brace, and then it'll be like JSON object, like this, something like that. And then the other curly brace, right? and these would normally be in quotation marks. Now, if you were to pass this into a large language model, it normally would process it fine, but somehow when you use Grok and you pass that in to the large language model, it's like, I don't know how to handle objects. And you're like, don't handle it as an object. You should handle the whole thing as a string, as if it were text. But anyway, so to fix that, I'm using OpenAI. And OpenAI, I'm only using the 4.0 mini because it is so cheap. The 4.0 mini is 0.015, I'm sure, dollars per million tokens. Per million tokens. So for reference, if we go to the OpenAI API key, we'll go here, OpenAI Platform Playground. And if we open this up, and I'll just go to API reference or dashboard, and then API keys. So I have a bunch of API keys. If we go to usage, and we'll see how much it's actually used. I'll not use cost, we'll use activity. You can see that today I've run, I don't know, 10 queries or something, and it's used 40,000 tokens approximately. Oh, yeah, 40,000 tokens. And let's see it, 40,000 tokens, 30 of which is uncached, 10,000 of which are cached. Uncached are more expensive because you have to go through an extra layer to go and get them. But if we see the OpenAI API prices, we go in here, 4.0 mini, you can see, I was out by a zero, but it's 0.15. So if we go back to my Scala draw, let's get rid of that zero here. And 1.5 by a million, which means that for my 40,000 that I've used, give or take, right? That means that it would have cost me 0.006 cent, meaning that the cutoff here is for a cent, meaning I've spent less than 1 cent for my 10 to 15 queries where it's went and scraped websites, brought them back, sold them in a vector database, blah, blah, blah. So basically, if you want something that runs fast and it's good, use the 4.0 mini. This one here, 4.0 mini. But if you absolutely cannot spend any money, you just don't have the access or available funds just in case, whatever, right? Then try Grok. It probably won't work unless you find a workaround for JSON. But the other option is Hugging Face, which is a place where you can run models, check out datasets, etc. So on Hugging Face, which we'll go over later anyway, because we do have to use Hugging Face for the free RAG embedding. So anyway, now we know all that, let's get into the actual building, because now we understand the decision making process behind everything. So let's go. Right, so the first thing you need to do is sign up to n8n. I'm running it locally. If you want to see how to do that, I do have a video all about it. It'll be carded up here, like will also be in the description below. It's super simple. Essentially, you just run npx n8n, and that's it. It runs, which is brilliant, completely free. Or you can do it online, 14-day free trial, and then you have to pay $25 a month to run it online. So I suggest run it locally. So the first thing I want to do is create a workflow. In this workflow, we have here plus the first step. We'll click first step, and we shall do on chat message. Now this essentially is going to create a chat interface as if it was like ChatGPT. So let's click it here, and we have this now. When chat message received, you'll see this pops up at the bottom. If you click on chat, you can say hi, and then nothing will happen, but it will say successful because it's not connected to anything. So let's connect it to an AI agent. So if we search nodes up here, we go AI agent, click on that. And then if we do here, agent, tools agent, because it's going to be given tools. Source for prompt, user message, connected chat trigger node, which is what we just added. And the input will be JSON chat input, which is this here. So in this input, you can see schema, table, JSON, and you can just drag and drop that in. but it just automatically finds it from here. So, all good. So we now have an AI agent which receives messages. This AI agent, for reference, is just a framework. So we have to add in the model, we have to add in the memory, and then any tools that we want to add in. So first let's add the chat model, because this will actually turn it into a chat bot. So these are all the ones we have to choose from. I am going to use OpenAI, and I'm going to use Foro, just because it's nice and cheap. So credentials to connect with. You can connect with your credentials here. If you click create new credential, all you need is an API key. To get that, if we go API keys, OpenAI, then we have this OpenAI platform playground. And from here, we'll go to dashboard, and API keys will be here. It's a long way for a shortcut, but we're here. And then we create a new secret key, and essentially this is going to be our key that we use, like as if it was a door, to get into API, to get into OpenAI and use their models. You need to keep this completely private, because if someone gets it, they can use it, and basically OpenAI thinks it's you, and you'll get charged. So just beware. I give it a name and then click create secret key, and it'll pop up. Or you know what, I'll just do it here. n8n local 2. Create a secret key, and here it pops up. Click copy, and then done. And it's gone forever. You won't be able to see it again. But if we go back to n8n, we can then paste that key in here, and then save, and then it'll automatically save it. There we go. Automatically add you in. You can now select the model. We'll just go 4.0 mini, but you can see there's a bunch of models, so you can like preview audio. So you could say use your voice and then get the actions from that. But we're just going to use the normal one, and that's, as you can see from the asterisk, the only one we have to add. So if we go back to chat and we just say hi again, which you can also do if we go back here, you get 2 bits that pop up. One here, repost the message, one reuse. If you reuse, it just pops up here, and then you can press enter. Or if you repost, it will then repost the message without you having to do anything else. So you go, hi, how can I assist you today? And we see we now have these logs. So this is all working perfect. Input system, you're a helpful assistant. Human, hi. Output, hello, how can I assist you today? So go into the AI agent and open it up. We can see if we add options here, we can do system message, and this is where you can change what it thinks it is. So you could tell it it's a marketing assistant, or it's a script writer, or whatever you want it to be. So we have that, that's cool. For the memory, let's add a window buffer memory. It's the easiest one to do. Context window length is how many messages do you want it to remember. If we do 5, that's fine, because what we can do now is if we say, hi, I'm Luke, say hi Luke, and then if I say, who am I, then it'll remember it. Yo, Luke, blah, blah, blah. But if we reset the session up here, so it's like opening a new chat and I say, hi, who am I, it won't know, because this memory is relative to the session. So, now, the next thing we want to do is add some tools. So, let's move these out of the way, like so. And we want to add some tools. So, the first tool we're going to add is our subflow, which is our web scraper. So, click on tool, you can see there's a bunch of tools. If we do the first one, call n8n workflow tool, this will call another workflow. So we're going to create this new workflow. Now, the name we're going to give it is web scraper to vector DB, because that's what it's going to do. It's going to scrape a website, it's going to get that info, turn it into a vector database. And then as for the description, we're going to put this in here, which is call this tool to get info from a website, i.e. scrape, given a specified URL. This info is then pushed into a vector database, so you need to call the vector DB again after running this. Now the name and description, these are detailed so that the AI agent can use this tool and understand it, because it's a large language model, so it has to understand the language you give it. Right, and now the workflow from list. For here I have a bunch, but you won't have any, probably. So create a new sub workflow, click there. Now this is where we're going to create our web scraping workflow. So we have the first one, which is when executed by another workflow. So that's the trigger. It's triggered by our AI agent. And after this, we want to replace this with our logic. So let's delete that. And then we'll click on the plus. And from here, we want to write an execute because we want to execute a command. So what's going on here? Why are we going to do this? So let me show you. So I watched a previous video. I think it was Crawl4AI, something like that. He does a bunch of AI videos. But he was showing you how to do this on n8n using Docker. I thought it seemed a bit complicated. Couldn't we still just use Python? And I found out that we can. So, because we're running this locally on our own machine, we can actually use our own machine's resources. So for example, if we run this execute command, this will run commands as if you were on terminal on the computer. So for example here, if we were on terminal like this, so for example, if we do echo hello, echo just means write it back to me. We do echo hello and it'll write it back, hello. We can also run Python, whatever, from our terminal. I can do the exact same thing here. So the execute command node, what it does is it executes commands as if it was your terminal, because this here, localhost 5678, is actually running on my computer. It has access to the resources that any program would have on my computer. So for example, it can access my Python, right? Whereas if you're running this on n8n.io, the cloud platform, then you'll have to install Python using this execute command. If you want to figure out how to do that, then ask ChatGPT and it will give you something that might work. But essentially, terminals like this here, if we clear that, and if I write like echo hello world, and then it will send that back out. And if I do something like Python 3 -- version, you can see that Python has been installed. If you don't have Python installed, install Homebrew if you're on Linux or Mac, or install Chocolatey if you're on Windows, and then use that to install Python. Have a quick Google, ask ChatGPT, easy enough. So from here, I'll be able to access that Python. So let me paste this code in, scroll it down. So this is like using my terminal. So I have Python 3 version just to make sure that it does have access. And then we're going to create a virtual environment. We're going to go into that virtual environment and we're going to install Crawl4AI. So the reason we're doing this here is so that it doesn't install Crawl4AI in my entire system. I only want it to contain it within here. Then after that, we want to pip install our Crawl4AI. Pip being Python package manager. Basically installs modules and libraries and packages like Crawl4AI. And then we do Crawl4AI setup, which if we go here is the way that we set it up post installation. So this is our quick start instructions, is pip install Crawl4AI and then run it. So we'll go back here, then we run it. And then after that, the way you would do it if you were writing the actual Python file is you would write it like this here. And you'd pass in the URL, and then that would be you. You just run this script. So we can actually create this script, like create this file from your command line, so from terminal. And the way you would do it is echo, and then you have it in here like this. And then you have this like output arrow into a file called crawler.py. And then we can run that file like this, Python 3 crawler.py, and that will run that file, which is cool. Because now what we can do is create files from this execute command and then execute them. So this here creates a virtual environment, creates your file for your crawler, and then runs it. And in the middle here, we can see that I echo this Crawler4AI and then my name, Luke J. Byrne -splitter. The reason is because I'm going to use that so I can split out the output in terminal from this first chunk here to this part here. Why? Well, because when I run Python 3 -- version, for example, here, you can see that it gives this output. Well, the output of execute command is your terminal output. So it will have Python 3.13.2. And then when I do this here and that, and then the pip install, it will have all of this output on the command line, which I don't want. I only want the output from here. So we use that to split it, which we'll show you when we actually run this. So we now have scraped the web page. Simple as that. The next thing we want to do is we want to get that scraped portion from terminal. So if we click plus, we then write function, and we're going to get this code here. So we're going to run custom Python code. Click in here, or JavaScript. I'm just going to paste this in here. And what this does is it gets the output from our scraper, and it creates a variable called output. And then we create a variable called match, and we match it to what I had just shown you, that Crawl4AI JSON splitter. And it's basically what that does is it splits the whole chunk of text that we get into two parts. The part before Crawl4AI JSON splitter, and the part after. And we only want the part after, which is what we do here, return match, and it's that match in square brackets is 1, because match will then be an array of size 2. An array indexes start at 0, so you have 0. Match 0 would be everything before this. Match 1 would be everything after. Or if we don't have anything there, then no relevant data found. So before we're able to test this, we have to give it an input schema, because you can see there's an error here because it can't be executed. And that's because we don't know, or the AI agent doesn't know, what information am I supposed to give this here. So the input data mode, we're going to use JSON, because it's the easiest way for us to move stuff around and work with the data. And what we want to pass in here is this HTTP request URL. So the example that we're telling the agent is we want you to give an HTTP request URL, and here's an example, https google.com, right? And now, whenever the AI agent runs this, it will try and guess what this should be. Or it'll make an educated guess. So if we go to execute command, if I open this right up, you can see here, actually within the URL, I have this here, and that dynamically gets that value that I just shown you. But for the time being, if we just paste in this google.com, so let me Control A and Control C and then go forward. Now what we can do is we can test this just with google.com. And if we test this workflow and open this up, we can see that HTTP request is null. That's because we don't pass any value. But we've defined it as Google. You can see now it's popped some stuff out here. What's it popped out? Well, standard out, you can see, and this is the reason we have this splitter, is at first it's like Python 3.13, that's what we've got, and then requirement already satisfied, blah, blah, blah. These are all because we're trying to install and set this up. So we don't want any of that information. But if we keep scrolling down, we can see we get to a point here with the square brackets where it starts to run Crawl4AI. So just before here, we have our echo crawl, blah, blah, blah. You can see that exists right there. So then everything after there is actually Crawl4AI getting information from Google. So you can see fetching google.com, processing it, scraping it, complete. And then everything then from here, this is all from the google.com initial web page. So if we go into our code, we can see that the output here gets everything after this here. We'll just leave that. But this all is removed. This big chunk at the beginning, this Python, blah, 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 is all removed. And now we only have the web page. So perfect. It has crawled successfully. And we've gotten all of the stuff here. So let me redo this dynamically. So I'm just going to paste it back in. And you can see that it doesn't look highlighted or anything. And that's because if you see up here, we're in fixed. We want to go to expression, because then it's dynamic. It's a function. If we paste that in, scroll up, you can see it's now green. And the reason it's json.http request URL is because that's what it's called here. So basically, to get this, if you're making things like that, or you just go over and drag and drop it, and boom, simple as that. So that will now work dynamically. So once you then have this web page scraped, as I was saying in the Excalidraw example, bring this over, that we don't want to pass this entire page in. We want to chunk it up so that we only have to go and get the 1, 2, 3, whatever pieces of the page that we require, not the entire page. So how do we do that? Well, we're using a vector database. Specifically, click plus, we're going to use a vector DB called Superbase Vector Store. If we go on there, then we'll click on Add Documents to Vector Store. Credential to connect it, I already have one, but let's show you how to do that. So if we go on Google, Superbase, Vector DB, you don't have to do the Vector DB one, just Superbase. Open up any one and then sign in or sign up. Once you've signed in / signed up, go to your dashboard and then access tokens. And from here, if we generate a new token, give it a name, n8n local 2, I think I called it. Generate token. And there we go. So successfully generated a new token. So we copy this token and we go back here. Oops. Click on new credential. I thought that actually. Interesting. Right. So once you're on. So log in or sign up. And then from here, if we go to dashboard, and then from dashboard, let's create a new project. Choose an organization. You'll have to create a new organization probably. For me, it's just my name. We'll give it a project name. So call this n8n Internet Agent. Database password. Let's just give it something. Let me try again actually, because I mistyped. There we go. Region closest to you. I'll go UK. And then let's create this new project. And this will create the project where we're going to have our vector DB. So now that we have this here, the way that we're going to access this project is using the project API keys. Specifically, if we go here, I've already clicked into it, but if you are on your Superbase vector store, credential to connect with, create new credential, it asks for your host, so your project basically, and then your service role secret. So if we go back here, we can see that we have this service role. Now, the reason we use this is because it says this key has the ability to bypass role level security. Now, what does that mean? Well, it's that not only is your table secure, but every role is securing your table. Whoops, what's happened here? Essentially, that bypasses all of your role level security. So if we go to project settings, and then from here, we scroll, data API on the left, and then from here, we have our service role, so we can reveal that, and then copy, shut your eyes, don't share it with anyone, as always, paste that in here, let's go back here, and then the project URL, let's copy that URL, we'll bring that back here, paste that in, and save. And there we go, so we're now connected to Superbase. Operation mode insert, that's what we want to do, insert. And then table name, so from list, we'll go and find the tables you currently have. We don't have any. So if we go back to Superbase, home, you would think there'd be a button to just create a nice table. There is not. However, on here, if we go to docs, on these docs, Superbase Vector Store Node, you can see that Superbase provides a quick start for setting up your vector store. So if we click on that there, we can see that we have initializing your database. So prepare your database with relevant tables. Because it's a vector DB, it requires specific tables, and this SQL query creates them for you. So if we copy that from here, and we go to back to Superbase, and on the left, if we pop that open, we can go to SQL Editor, which will pop open here, and we paste that in, and then run, and it will run, success node, rows returned, because the query actually creates things, it doesn't query stuff. So now if we go back here, and I'll click something and click back in, see if it pops up, you see, get it to refresh. How am I going to do that? There we go. Right, so now we're back on it. We have documents or match documents. This time we're going to click Documents because we're going to be pushing them in. We don't want the match, we want the actual documents. So from List, Documents, Insert, perfect. Now, for our vector database, if you're aware, which you may be if you've used RAG before, you may not be, but essentially the steps are, number one, tokenize, i.e. split. So tokenize. Then step number two is embed. And then step number three is to then insert or upsert. So let's just write insert. So basically we have text, we want to break that text up, we want to turn that text into numbers, and then we want to put it in the vector database. So what we're going to do is, if we go back here, click out, you can see we have embedding and document. You can't really see the bit that says embedding, but we have embeddings and document. So for the document, let's click on that first. We're going to use the default data loader. And for here, we want to specify what is the type of data that we have. And it is going to be JSON, because we can see here it's in JSON. And we're just going to load all of that data in. But if we click out here, we can see there's a new mandatory one, which is text splitter, i.e. how are you going to chunk it up? And for us, we're just going to use the recursive character text splitter with a chunk size of 1000 and no overlap. That's fine. And so now we have our chunks of 1000 broken up. So the next piece we need to do is the embedding. So if we click on plus, get embeddings, and we're going to use Hugging Face inference. You could use OpenAI, I suppose, which would be fine because I think if we click on it, we're already connected. If you want to do it free, you can use Hugging Face, which I'll show you how to do. So if you plus here, embeddings, Hugging Face, you can see that I'm connected. To connect, if we go to Hugging Face and you create an account in here, so I have a profile here, it's just me. Why do I love a love heart? I like the space. Well, there you go. So Hugging Face, a place you can get free models, API embeddings, etc. And what we're going to want to do is create an API key. So if you click on you and then go down to access tokens, confirm your identity with your password. There we go, we're in. And from here, we want to create a new token, which is just your API key. We'll give it a name, so we'll call it n8n internet agent. And then from here, all you're worried about is this inference, and you want to just make calls to inference providers, i.e. to models. And then go down, and we want to create token. And that's it. And then you copy this. Again, don't share it with anyone. I'll have deleted all of these by the time you come to do this. Create new credential, paste it in here, click save, test it, successful, and boom. And then for the model, we're going to use this here. So, oh sorry, not that one. We're going to use a better one. So if we search up top, we'll do Hugging Face, embedding models. So click on the first one, models. You can see there's a bunch of models here. You can see they're all embeddings models. But the one that we're going to use is, I'll just paste that in because I have it on the other screen. But this one here. And that's just essentially a random one I found online, which has the same number of dimensions as the line chain thing here. Because you can see here that the embedding vector is 1536, which works for OpenAI embeddings. Dimensions is the number of dimensions in your vector database. For example, this here with an X, a Y, and a Z, that would be 3 dimensions. So imagine one with 1536 dimensions. But anyway, so this works with that. So we're going to use that. And that's all we have to do. And that's going to then use these embeddings. So this will be called by the AI agent with the relevant HTTP URL. We then execute some code to basically do the Crawl4AI scraping, web scraping. We then have more code which gets the relevant data that we need from here. And then we have the Superbase vector store which then stores it. So let's go back to the original one. We now have our web scraping tool, which is cool. But the problem is, from here, the output isn't really actually anything, because the whole point of this tool is to push it into the vector DB. So what we want to do then is we want to create another tool which searches the vector DB. So for this one, if we search vector DB again, so vector, and go to Superbase, because that's what we're going to use. And now you might have to create a new credential again. I'm not sure how it works actually on your local. I think you may need to create a new credential. And then the operation mode for this one is retrieve documents as tool for AI agents. And then the name we're going to give it is this here, get from vector DB store. The description we're going to give it is get documents from vector DB store. This store is populated from Crawl4AI web scraping. And then the table name, we'll check from the list, and we want match documents. And then limit 4, that's fine, and we'll just remove the metadata. That's cool. And then as for the embedding, we want to do Hugging Face, and we want it to be the same one again. Oops. How did I get that again? Be this one here. Sang Mini, blah blah blah. If you want to get that from here, you can just go there, copy, and then paste it in. Cool. So we've now got that vector DB, and then we know the embeddings because your query will be embedded. Tell me if that so you can see it better. Your query is going to be embedded, and it has to be embedded by the same model so that it can be compared to the same vectors in the database. For example, if we have this here, you know, some values, blah, 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 right? That if these values have been inserted by embedding with that model, then different models embed differently, so they'll have different values for the same thing. And so you want to use the same one. Just it's like you want to translate it into the same language, essentially. So we'll go back here. That should now all work. Moment of truth there. So let me rename this just so that for our own understanding. Let's call that web scraper. Rename that. Get from vector store, that's cool. Let's go to the sub workflow and we'll rename this. I don't think the AI has the knowledge of what it's called, but we do. So it's good practice to name it something so that when you go back to look at it, you can know what it is. Crawl4AI into vector DB subflow, and then this top level one, we'll name it Crawl4AI, or actually let's call it n8n internet agent. Cool. So moment of truth. Let's give it a try. So we'll say, what's something you'd only know on the internet? What was Elon's bid for OpenAI? Like 90 billion or something. Let's see what it does. So, OpenAI chat model. Then it goes to the Superbase vector store. It will try from here to find information. And you can see this all from the latest logs here. So let me zoom this up, zoom that out. So latest logs from AI agent nodes. So the first one is buffer memory. The only memory it has is, hi, who am I? So the output is nothing. OpenAI chat model. So it then passes in, you're a helpful assistant, the human memory, and then the AI, and then the human's next message. Whoops, let's see. Vector store, blah, blah. It goes through the vector store, searches for some stuff. Then it goes for Hugging Face inference. OpenAI chat model, blah, blah, blah. Couldn't find anything. Blah, blah, blah. Couldn't find anything. Right, so possible reason it can't see anything is because the AI agent needs a little bit of guidance. It is a model. It's essentially a black box. And so for this, I find system messages to be super helpful. So I'm going to give it a system message and say, always check the vector database first, and always check the vector database after each web scrape, because it needs to know to do that. Then a tip is that the best way for searching is using Google, e.g. https google.com/search q blah blah blah, right? And if we come out of that, and then we can send the same thing again, but we'll click on reuse message and reset the session so that it doesn't try to give us the answer of I don't know because it's in its memory, and resend that again. And this time it should go in the vector DB, yes, and then into the web scraper, perfect. And then from this web scraper, it will then push it in, and bring it back, right? So we have an error. So if we stop this, wait, did that actually finally work there? Have I messed up? Don't think so. So I think there's an issue here in the code. So the way to find the issue for that web scraper is if we go to our other one here, our subflow, go to executions, we can see here all of the executions and when they've happened. So execute command, you can see that's where it's went wrong. If we double click, command failed, Python version, blah, blah, blah. What's it saying? To run main echo crawl, and new release is failable. So the command has been failed. Let's see how. Invalid URL. So HTTP request URL is null, and it'll be passing in null and trying to use that. So let's have a look. Why would this AI agent be passing in null? So if we open AI agent up, because I think actually I know why. So if we open the web scraper up, we can see our workflow inputs now. Now this here, HTTP request URL, is to match, if we open this up, the HTTP request URL here. So if we go back here, we can either give it something fixed or an expression, or if we click this little magic icon, we can let the model define this parameter. So we can say, let the AI agent decide this here. So let them decide what the request URL is going to be. So now we've done that, let me copy that, reset the session, and do it again. So vector DB, back to the chat, into the web scraper. This is the moment of truth. Now the web scraper, it might take a minute or so because it has to go get the HTTP request online, bring back that information, parse it, change it up a little bit, embed it, and push it into a vector database, which can take a bit of time. So then it's gone back to the model, which has then checked the vector DB, which has then decided actually that it has to go back into the web scraper, which is often not a good sign because then it's having to go in twice. And normally it's because it didn't get good information on the first try. So we can see if we click on web scraper here from the latest logs that the query that it's sent in is Google search Elon Musk bid for OpenAI, and then it'll have gotten back all this scraped info. So this here is just part of it. I'll show you in the executions after it runs this what it actually looks like once it's properly parsed everything. Because this is only one chunk of, I don't know, however many chunks it would be that are going to return, like 80 maybe. So let me see, why is it just continually going back and forth? What's its most recent ones? Right, so let's see. I couldn't find specific information, including whether it was around 90 billion. The details of it, such as might be widely reports, may not confirmed figure available on the discourse. Interesting, right. So anyway, what we can do is if we go to web scraper, we can go and see what it's been scraping. So if we go on here, you see these have then popped in. So it went in 4 times. So first time, if we click on this, we can see what it's been looking for. We open up execute command, we can see that it's tried to look up Elon Musk bid for OpenAI. Then it gets all of our information back, especially from the Google search. And then we get only the bit we need. And then from there it goes out the vector DB. And the way that it's stored, and as you can see here, that we have 3 pages that it's stored of information, which is put into chunks. So we have the first chunk here, and the second chunk, third chunk, blah, blah, blah. Page content, OpenAI rejects Elon Musk's 97 billion bid. So that's getting pushed into the vector DB. So now if we come back out to go here, one would have thought that this vector DB run would have found the relevant information. So let me check here. what has it brought back? So Elon Musk OpenAI bid value on the left for debugging, that's the input. On the output we have 4 runs. So if we look at run 1, let me Command F, bid, that there, see. Right, so none on here. Number 2, none there, 3, none there, and 4, none here. Right, just to test my sanity, we're going to bring back the one we used to have, and we're going to ask it the same questions. So, we'll say, what's the latest news on Elon buying OpenAI? Paste it in here. And let's see what it does. Vector, goes back to chat, checks it, web scraping. We'll do a little bit of web scraping. And then it should come back. Let's delete that in the meantime. Boom. So, let's come back with actual information. The latest news regarding Elon Musk's bid for OpenAI include the following bid details: 97.4 billion bid, 100 billion offer rejected, blah blah blah. I can find more details here. Right, so the old one works. What's happened? What's the difference here? Right, so let's delete all of these again. I'm going to try it one more time because I've changed. It turns out that the chunking was 500, not 1,000. So let's try. What's the latest news? Elon buying OpenAI. Save that. So vector DB, there's nothing in there. So the model's going to think, and then it's going to give me some info. How's that finding it? Oh, it's finding it from my memory. Why did it give me the exact same info? Oh, is it from my vector DB? I thought I cleared the vector DB. Let me see. It's using a different DB. Interesting. What's happening here? Is it from memory, maybe? That is weird. Let me try that again. Because that vector DB should be completely empty. Yes. So it must have been from memory. So maybe the chunking has been the issue. So if we web scrape now, should push it into the vector DB. So it should go search again, bring the info back, process the info, go on. Boom! And we're back. Haha. So the problem was the chunking. The chunking has to be 500 and then it will work. But there you go. So there you have it. We can now search stuff online. What's the latest news, Elon? Nearly 100 billion offer, 97.4, which is exactly what it is. If you check it out, we'll go online. Let's see. Elon Musk bid, OpenAI. It's like, is it 97.4? Oops. Elon Musk bid, OpenAI. 97 billion. Boom. So it searches online. That is well cool. So there you go. There you have it. I hope you enjoyed. If you did, like, comment, subscribe, all that good stuff. Link will be in the description for Applied AI Community. I'm starting a new community for AI enthusiasts and entrepreneurs to learn stuff like this and to actually use them in the real world. If you're interested, the link will be below. Anyway, like, comment, subscribe, all that good stuff. And I'll see you in the next video. Take care.